Cool. Thank you very much, Zoom lady. I should probably check this first, but can I just clarify, folks, that we can see my screen at the moment? We're just seeing a GitHub repo. Beautiful. Thank you very much indeed. So what we're going to be working with this morning is just an example repository for the NC News sprint that you're on. I've called it NC News. And in terms of the actual code, okay, let me just head to VS Code here. We should have a very, very similar file structure to what you have yourselves. One thing I would just like to point us towards is in terms of that connection.js, my connection file here is as yours will have been following your hosting setup from yesterday. Okay, so an alternative config object for when our node environment is production, because we want to be connected to our online hosted database. Other than that, everything should be the same. Cool. So what are we here for? We're going to take a look this morning at CICD, continuous integration and continuous deployment or delivery. So before we just have a look at what that means, just some of the things I'd like for us to cover today. So we're going to have a quick exploration of some branch protection rules on GitHub. I'd like for us to be able to understand the benefits of CICD and automating some processes in something called a pipeline. We're going to explore this via a service available to us called GitHub Actions. I'd like for us to understand how and why to hide sensitive data with secrets on GitHub Actions. But we'll get to all of these points as and when. Okay, so can't be on the timeline. Continuous integration and continuous deployment. So integration, this term just referring to effectively the integration of code, right? The introduction of new code or features into an existing code base, and crucially, upon the integration, making sure that everything works correctly, right? Before we're actually introducing some more code from a separate branch into another one. Now, in terms of the integration, you've already been practicing this this week, okay? In terms of your feature branch approach of creating a new branch, you've got your own isolated environment, your own specific Git timeline to work on that specific feature, and then via a pull request, merging that into main. So, and all the tests are working on that new code. Upon merging that in, we would say that that's our integration of that new code into the existing code base. And then the term deployment is making your actual software or software updates available to your customers, or releasing code into a production environment. Okay, so the very notion of in your case yesterday, it's like hosting, right? Being able to get the code that you've been working so lovingly on and being able to release it out into the wild, deploying that or being able to deliver that to our customers. Okay, and the term sort of like continuous here, so continuous integration, continuous deployment, this notion of effectively automating these processes, right? So far, all of these steps have been fairly manual, right? Whenever you're writing some tests, you're going to run those tests manually, and then once you're happy with those, you're going to commit, push up to a branch, and then you're going to submit a pull request, merge that branch into main when happy, right? So in terms of the deployment, for those of you that have already hosted your application, this part is effectively already automated, right? The service that we recommended and pointed you towards being render keeps an eye on your main branch on GitHub, and whenever it detects a new commit on there, it will clone the repository and update those changes and make the live service reflective of that new code. Okay, so CI/CD is something that's very common to the backend world and indeed software development in general. I feel like, not gone are the days, but we rarely see anymore the notion of working towards a completed version of some software, releasing it, and that's it. I always sort of think back to I had an N64 when I was a kid, right? It's like you get a physical cartridge. There's no day one patches, right? There's no updates that can be issued. That software needs to be fully working from the off. It's quite a common approach nowadays. Sort of a minimal sort of like version of the code can be released out into the wild, get some customers using it, and while it's out there, developers can still continue to work on the project and add new features and release updates as it's out in the wild. So that's the sort of process that we're going to be having a little look at today. Okay, as I say, so far, these steps have been, the integration phase has been fairly manual, okay? Now, at the moment, you're all working by yourselves on this project, right? And one thing I would say is you could have, let's say, the best test suite in the world that's very robust and make sure that everything is indeed working. You could, for example, just forget to run your tests before pushing your code up, right? And you could end up pushing some code that is indeed broken to main and introduce some breaking changes. You should all have like Husky installed locally, which will aim to prevent this. But let's say Husky isn't installed correctly, and I'm aware that that's actually the case for some of you, where you are able to bypass running the test before pushing that code up, for example, right? So if, for example, we're working on a project in future with many collaborators, okay, very rarely are you going to be expected to work on unless it's a bit of a passion project that you're just working on in your spare time, on a piece of software independently. You will be working with others, and spoiler alert, you will be working with others in 4 weeks' time once we get to the project phase of the course, right? Let's say, for example, different collaborators are working in different environments on and the code works on my machine, right? But it doesn't work on another collaborator's machine. Let's say, for example, there's some sort of operating system quirk, like I'm working on a Mac, but I'm working with a collaborator who's working on Linux. It works on mine, therefore I'm comfortable. It would work in the real production environment, but then it turns out it doesn't, and vice versa. Let's say I have, for example, a node module installed globally, like Express. It's not part of my package JSON or something like that, and it's installed globally on my machine. So the code runs expected in my environment, but not in a shared environment where we expect our production code to exist. So one thing I'd like to have a look at first is a way that we could put some barriers in place, put some restrictions in place to ensure that these actions are indeed carried out. Okay, the tests are always run before that code is able to even touch the main code base. Okay, and I'd like for us to be able to run that code in an environment so that all the tests pass, an environment that all collaborators agree on, and it mimics the production one somewhat. Okay, so we would be able to do that via something known as a pipeline. Now, what is a pipeline? A pipeline is effectively a series of actions that could be sequential. Okay, so running some, running like some smaller scale tests, some unit tests, then perhaps running some integration tests, then deploying once all of those pass, like a series of processes that could be automated. And a pipeline will run on a virtual machine. A virtual machine just being a simulated environment where we could have access to an entire operating system. Again, hopefully an operating system that would mimic our production environment to run these actions on. Okay, so this is my very detailed sketch of a pipeline that has a point of entry and a point of exit. Okay, and in terms of sort of like my example, I would like to begin by running some unit tests. Okay, so as soon as I, for example, push some code up somewhere, I would like to run some unit tests. The unit tests being the small scale ones, and they should be fairly, fairly inexpensive computationally to run some unit tests. If those unit tests pass, then move on to some integration tests. That's what you've been doing this week, right? Now, one thing just to bear in mind is the actual the use of this virtual machine may be costing money to your company, right? So it might make sense to let's run some smaller scale tests first, the unit tests, because if the unit tests fail, there's no point running our bigger test suite on our data with our database involved in the integration tests, because it's destined to fail and it would be wasted computational expense. So there's a reason that we might decide to have a sequential order for all of these tasks. Okay, following these integration tests with our local database, I would like to then progress to running some integration tests on like a live database. So just running the exact same tests, but interacting with, say, one that we've got hosted on like Elephant SQL, for example, just to make sure that all of that behavior is replicable when interacting with a real database. Okay, and then following all of these, I would like to deploy to render. Okay, which is in our case our production environment. Right. So once all of these checks and balances have passed, getting to our deploy stage and actually being able to release that update of whatever new feature we're working on to our customers and have it live and running. Okay, so At the moment, right, at the moment, we're deploying to render, okay, on, say, a push to main, a push to our main branch, or a merge to main, okay? So as it stands, there's nothing stopping a rogue developer that we might be working with from skipping all of our requirements for wanting to do the tests and just pushing straight to main and just effectively potentially breaking, introducing some breaking changes that would then end up getting deployed to our real version, right? So what I would like to suggest is we need this pipeline is our sequential processes that would need some sort of events to occur to trigger its execution. And what I would like to suggest is I'm going to want to trigger this pipeline on a pull request to main. Okay, so whenever we've completed a feature and we've pushed to our branch and we submit a pull request, upon submission of that pull request, I'd like to trigger all of these events to take place. Okay, so first and foremost, let's just quickly look, folks, at how we can make sure we can't have any rogue developers just bypassing our system that we'd like to put in place and pushing straight to main. So let's take a quick look at that now. So I'm going to just head to my GitHub repository here, and I'm going to take a look at something called some branch protection rules. So I'm going to head to branches here, just go to settings, in general, branches, and I've got a default branch here, which is main, and it's saying, oh, you haven't protected any of your branches. Would you like to add a protection rule? I certainly would. So if we come on here, branch name pattern, so we can just type the name of the branch that we want to add some restrictions to, and I would like to add one to main here. So there's quite a few options as to restrictions that we can provide, and one of which here is require a pull request before merging. So I'm going to select that, and that's going to now mean that it says here, when enabled, all commits must be made to a non-protected branch and submitted via a pull request. So it's just enforcing what we've already been practicing this week, folks. I can then also here have require approvals. So I can make sure that I can't just submit my own pull request and then silently merge it myself, right? Which that's what you're doing at the moment, folks. And I would like to say that no, I don't recommend it at all. You could, in theory, emphasis on in theory, ignore all of the feedback that a tutor has given you and just merge it in anyway, right? So I'd like to put some restrictions in place to make sure we can enforce that can't happen. And I can say, oh, I would require an approval, and an approval is required. I can decide like how many collaborators I would like to approve this pull request before moving on. So to say I would like one person to at least approve this pull request. Cool. There are a couple of other things that we could take a look at, but one thing I would like to do is this last one here. It says, do not allow bypassing settings. The above settings will apply to administrators and custom roles within the bypass branch protections permission. And all this means is no one's above the law. Not even myself, who is the owner of this repository. I can't just suddenly skirt around my own rules. Cool. So then, let me just create this, this rule. That protection rule is now in place on the main branch. So I'm going to come back to my code here. Okay. I'm going to come back to my code, and I'm going to come to app.js, and I'm going to, for example, I'm just going to console log an undeclared variable, something that would cause a reference error and cause everything to break, right? I can hopefully clarify that if I run, I've just got a script just to run the application tests here. Cool. And we can see that we do have a reference error, right? None of the tests have worked because it's broken. But I could just decide that I would like to push this up anyway. Okay, so if I were to now, so I want to git add that change. I want to commit with, don't ever commit something like this, folks, but breaking code. And then if I now attempt to git push origin main, cool. I'm going to push that up here. I am turned away at the door. Okay, I've got an error. Protected branch update failed, and it tells us that at least one approving review is required by reviewers with right access. Okay, so I've now made sure I can't even accidentally push to main. So one thing I'm going to have to do here is I'm going to have to head to a new branch. So git checkout, I'll use the proper spelling, git checkout -b, and let's just say let's call this a brand new branch. Cool. And just for the purposes of this, let's say I don't actually want to introduce anything that breaks. Let's just say for now, I want to, let's just add a quick endpoint of, so like, so like slash API slash hello. Just pass in like rec, res, and next, just so we can hopefully see a change eventually on the server. Okay, so I would like to say res.status of a 200.send object, a message of hello everyone. Cool. So I can now, I'm now on my new branch. I can add that in. I can add in a commit here. Git commit dash but like add greeting endpoint. Cool. Now I can push up to my origin of brand new branch. Cool. So then let's head back to GitHub. And this is the and this is just the process that you've been through so far this week, folks, right? I can now go and compare and pull request. It's able to merge. I would like to create a pull request. And cool. So I added in that breaking code initially, and now I removed that and added the greeting endpoint. And now I can see I am not allowed to just merge this straight in. I require a review. Okay, I do require a review. So I have taken the liberty of adding the wonderful Has as a collaborator to this repo. Has, are you there? Are you there at the moment?
I am. Hello.
Cool. Would you be so kind as to take a look at this, at my pull request, and feel free to reject it, but for the purposes of time, I would quite like to say it passes all of our checks
I'll
and
take
guidelines.
a quick look.
Thank you very much indeed. Wait for our review to come in now. Perfect. Thank you very much indeed. So now upon that review, thank you very much, Has supposes this is okay. Cool. That change has been approved. I can now merge this in, confirm that merge. Brilliant. So if we just head back to NC News, we can see that now the most recent commit was that branch being merged in. And a result of this, if I now head to my render dashboard, so this is only if you hosted yesterday, folks, but this is just keeping track of everything that's on main. It's detected that there's a new commit, and now it's going to be rebuilding the new version of the code and going to hopefully deploy that application. Cool. So at this stage then, we've protected our branch to make sure we can't just have rogue pushes to main. However, I could have still pushed some breaking code there. Okay, and whoever reviewed the code, there could have been something that just slipped through the cracks, and there could be something breaking here. Okay, so let's come back to thinking about our pipeline. At the moment, I've made sure that we must submit a pull request to main, and we must have a review before we can get to the deploy stage and actually get any code in main. However, I would like to trigger this sequence of events. So we can do that, and hopefully just while that will hopefully go and see shortly that at the moment, if I were to go to just /API/ hello, that I think it's just lagging a little bit here. That'll come up shortly, so we'll come to that. So we can now implement our pipeline via a service called GitHub Actions. Cool. So I'm just on the GitHub Actions homepage here. Now, what is GitHub Actions? It's a continuous integration provider. It's not the only one out there. Okay, so there are other ones. I think there's like Circle CI or like Jenkins or a couple of other ones. But it's familiar territory, right? Like GitHub's quite familiar territory. It integrates very, very nicely with the repositories that we're already used to. A free tier is going to be sufficient here. And as we mentioned a bit ago, like everything that we do in a GitHub action is going to be run on a virtual machine. So we can have, we can have environments for like Linux and Mac OS and Windows. if I sort of like quickly come down to the bottom here, and there's a little pricing tier sort of showing us on private repositories, you get like 2,000 minutes of computation time free per month. Anything extra, Linux is like the cheapest tier, 0.008 cents per minute. Windows is twice that. Mac OS is 10 times that. But it's also showing us that if it's a public repository, it's free. We're allowed to, we're just allowed to use as many minutes as we would like. Cool. So what do we actually do? How do we get this started? I'm just going to go and get started with actions. Okay. And I'm just going to head to quick start. And again, there's a lot of documentation here, folks. And I would like to say everything we're going to go through now is in your notes, very similar to the hosting process yesterday. If I said to quick start, quick start for GitHub Actions, try out the features of GitHub Actions in 5 minutes or less. Cool. So creating your first workflow. Now this term workflow is just sort of GitHub Action specific term for a pipeline, right? This sequential series of processes. Cool. It wants us to create a .github/workflows directory in our repository on, we're going to do that on root level. So let's just quickly go and do that now. So I'm still on, let me create another branch. So I will just say like git checkout from here, -b. I'll just call it like test GitHub Actions. Cool. So on root level, let's just close this out for now. I'm going to create a directory called .github. And inside of there, I'm going to create a directory called workflows. That's exactly what it asked us to do. Cool. And then it says just copy the following YAML contents into the GitHub Actions demo.yaml. Now, I'd like for us to do this ourselves, but we need something called a YAML file. Now, let's just quickly create that one, and then we'll talk about what that is. So inside the .github directory, inside of workflows, I'm going to create, I'm just going to call this like test.yaml, YML. So has anybody heard of YAML before, or this file extension, or is this a brand new one? Cool. Oh, and just quickly, while you're answering that, just coming back to the chat, Vesh, is the minutes in reference to the minutes that you use the CICD workflow, because 2,000 minutes isn't very long. So it's not like the timer started now, it's computational time once we start actually utilizing that workflow. 2,000 minutes is probably more than we need, but you know, for companies that have private repositories that want to make full use of this and they're going to exceed that, then they're going to want to they're going to need to fork out some cash, right? They're going to need to pay for additional computational time. I think it's like per minute, depending on the environment. Cool. Majid there was saying, what branch does this need to be on? Entirely up to us. I've just gone to another branch. I've just gone to another branch here to do this because I'm not going to be able to push it straight to main because of that restriction. Okay. So YAML is the extension just stands for yet another markup language, and it can be either .yml or .yaml. And YAML is effectively just a way of determining like config information. So it's very, very similar. It's very similar, folks, to sort of like JSON, key value pairs. We can sort of represent arrays and objects, like that sort of thing, just in another format. But that's the way that GitHub would like it. So I'm going to go through just a few steps here, folks. And again, everything is indeed on our notes for this one, right? So first and foremost, I need to give a name to this whole workflow. Okay, so I'll tell you what, let me just zoom in one here for now. So I'm going to give a name, colon. So this is almost like I'm declaring a key value pair now. I'm going to say that test. Okay. And I now want to determine, when does this workflow trigger? Under what circumstance do all of the jobs and tasks that we're about to put in play actually start? And I decided I would like to do this whenever there's a pull request submitted to the main branch of the repository. Okay, so this workflow will trigger. I'm going to give a key of on. And inside of here now, YAML is white space sensitive. So I'm going to need to indent in, which is effectively now showing this is everything that's effectively like an object on the key of on. Everything following is going to be inside of here. And I'm going to say on a pull request. Cool. And inside of here to list the branches that a pull request could be submitted to. And I'm going to say, I want to do this on the main branch. Cool. Now in YAML, this dash syntax is sort of a bit like an array. So I could list many branches here that when there's a pull request submitted to it, I'd like this workflow to trigger. But in my case, it's just on a pull request to the branch main. I would like to trigger some tasks. Cool. So then, what are these actual tasks? It's now time for us to actually define. It's now time for us to actually define what we want to do here. Okay, so back on the sort of top level, so the first level of indentation here, I need a key of jobs. And this is going to list all of the individual, and an individual job would be sort of our individual steps here. So like a unit test would be a job. Integration test with our local test DB would be a job, and so on. Cool. So just to sort of play around to begin with, I just want to show us that we're going to have access to a full virtual machine, right? And we can interact with that virtual machine just as we would effectively interact with our own, like, well, what's the opposite of virtual? Physical, a physical machine, okay? So I need to name this job to begin with. I'm just going to call this like greeting, just so that we can say hello to ourselves from the pipeline. So I now need to tell GitHub Actions what operating system I would like this virtual machine to utilize. And that's going to be on a key on of runs on. And we're going to use, I would like for us to use Ubuntu here, or Linux. And my reasoning for that is A, it was cheaper. We saw that on the actual, oh, sorry, I've come away from it. But we saw that on our, on the little sort of like pricing list here. Linux is going to be cheaper. And I've had a little look behind the scenes. Even though I'm going to be using I'm using a Mac, for example, for all my tests, Render will actually be hosting our application from a Linux environment. So a Linux environment is now going to be replicable of what our final production environment is going to be. So I'm going to say Ubuntu, and I'm not too bothered about the version. I can just say Ubuntu latest, whatever the latest version of Ubuntu is there. Okay, so we've determined the operating system, and now we need to say what steps will this job take. We can give each job individual sequential actions to perform. So I'm going to provide a key of steps here, and then this would now be similar to before. Dashes representing effectively an array. Okay, just quickly coming back to Michael's question in the chat there. Is the virtual machine accessed via SSH from our machine, or is it all done via GitHub and we just send them the blobs for all our files in a commit? Cool. We'll see that in a moment. This YAML file does not have any like executable code. It's just config information for GitHub. GitHub is gonna run all of these virtual machines for us, but we'll see that very, very shortly. Okay. So steps. What do I want this job to do? I can name a step, and I'm just going to call this, and this is just custom now. I'm just going to call this like say hello, and I would just like to run a command in the terminal. Okay, and if I were to say run in my terminal here, I just want to echo, and I want to say like hello peeps from the pipeline. Cool. That's a standard terminal command. But if I were to run this, it would just echo that back to the standard out. So I just want to run this exact command here. And if I want to run an arbitrary terminal command, I can use the key run. I'm just going to do exactly that. Run, echo, hello peeps from the pipeline. Cool. So then, let's see how this actually looks. In order to get this information on GitHub, I'm going to now need to add and commit this, right? So I'm going to git add this YAML file. I'm going to commit. I'm just going to call this like setup workflow. Cool. And I'm going to git push origin this new branch that I've created, just like test GitHub Actions. Cool. So we push that code up to GitHub. Let's head back to my personal repository here. And we'd said for this job to only trigger on a pull request to main. Okay. So once I create this pull request, cool. I need a review, but I'm not bothered about merging it at the moment. What I would like for us to see is, it's now telling us some checks haven't completed yet. I can now head on my repo to this Actions tab. And we can see here, don't worry about me messing around here earlier, this most recent one called Setup Workflow. It's finished very, very quickly, so we didn't manage to catch it in time. It took 1 second to do all of that, but let's have a look at what actually happened, folks, right? So this is the name of our file on pull request. greeting is the name of the job that we gave. So that's custom, so we can identify it later. If I come in here, we can now inspect what was actually going on. So effectively now we get like a terminal output from this virtual machine. So whenever a job is initiated on GitHub Actions, a brand new virtual machine is instantiated, right? So setup job is this first one. It was like current runner version 2.299.1. That's an operating system. It's using Ubuntu 22.04.1. That's like the latest version of Ubuntu. This like runner image, almost like an image here is just sort of a like a template for what an Ubuntu virtual machine is. Cool. And then there's some other information here. But once it's set up that job, there's so once it's set up the job, this was the first step. We then get to our own steps, and that say hello is the one that we named here. Say hello. Okay. And if we look inside of here, that ran a command called echo hello peeps from the pipeline, and we get to see the output in the terminal. We have access to whatever the terminal output would have been, just like if we're using a real machine. Okay, so GitHub Actions has set up our Linux virtual machine, run our command. It's done anything that we've asked it to do, and then once it's finished, it's then said this complete job, and then cleaning up orphan processes, which always sounds a little bit down. But effectively, this virtual machine was created to run our job. Once that job had finished and we got all of our output from it, cleaning up orphan process means this virtual machine now ceases to exist. This virtual machine has now been removed from GitHub servers. That little bit of computing space is now free for some other GitHub user to run one of their actions on. Okay, cool. So then, let's have a look at doing something actually useful here, right? So this was just for us to experiment that we have access to a full install of Ubuntu, and we can do anything with it via the terminal here. So then, coming back to our diagram, I would actually like to run the unit tests of our application. Okay, so how could we go about doing that? Now, this virtual machine, okay, this virtual machine that will be created is effectively a brand new Ubuntu instance, right? It will have a couple of useful things already installed. So it will have, it has Git commands like already installed. It will actually already have Node and NPM installed. There's quite a lot of things that are just very, very common for users to need on GitHub Actions that they come pre-installed for us, right? So I'm going to add another job. So on this level of indentation underneath greeting here, I'm going to create a job called test utils. Cool. And this job will itself run on a completely separate virtual machine. Okay, so for that reason, I also need to say what OS I'd like it to run on. I want it to be the same, but I need to define that here as well. So this is also going to run on the latest version of Ubuntu. Okay, and what are the steps that I would like this job to entail? Okay, so if folks, you'd got yourself a brand new machine, okay, and you'd got Git installed, you've got Node installed, you've got NPM, you want to get hold of the code in this repository. So in my repository here, NC News, what would you need to do in order to get hold of this code and actually run it? What would you need to do to get hold of this code, get it on your local machine and run the test, for example? What would you need to do? Because bear in mind that when we have access to this virtual machine, it's effectively like a fresh install of Ubuntu, just with a couple of useful things like Node and NPM already in there. Okay, let's say let's say you've been working on your past sprints throughout the bootcamp, and you've got your collaborator. Whoever was the initial forker is going to push that stuff up to GitHub. How can you, the collaborator, get access to that code? How can you get access to that code on your local machine? Cool. So Jake there says like git pull. Effectively, yes, but what would you do before a git pull? Ben there says a clone. You'd need to clone this repository down, right? Which makes sense in terms of a fresh machine, but that might seem like, well, aren't we already running this virtual machine on GitHub server with access to our repository code? It has access to our repository code, but we need to explicitly tell it to go and get our code. We need to effectively clone down the repo into this virtual machine. So I'm going to create a step here, and I'm just going to give it a name of checkout and clone the repo. Now, we could do all of this manually, okay? Just clone the repo into a specific directory and then CD into it, and we then need to install all of our dependencies, right? So we have jest and all of the dependencies in order to run the tests. This is a very, very common use case, folks, needing access to the code in the repository. So there is already a pre-built mechanism to allow us to do that. And GitHub Actions have a marketplace where there are loads of pre-built actions. Let's just quickly come here. There are 16,264 perhaps commonly used things that we might want to do inside of a GitHub Actions pipeline, okay? And one of the main ones is checkout, to be able to get hold of the actual code from our repo. And hopefully that term checkout isn't new to us, folks, right? When we want to check out a branch, right? Or check out to a specific version of our code. So if I come and have a look at this action, it's going to tell us how we can actually do this. So if ever we want to utilize a GitHub action that already exists, we, instead of using run, which is the command we used a bit ago to run an arbitrary shell command, we can use this keyword uses, and it will head to the GitHub Actions marketplace to find what we'd like. So we can say uses actions / this particular action checkout, and it's currently on version 3. So I'm going to pinch this line entirely. Cool. Put it here, although, sorry, for me, I've already got my dash because I've given it a name. It just uses actions / checkout at v3. And one thing to note is we can give it a repository that we'd like to check out, but it will already default to, and now it just says github.repository, the repository that this pipeline is attached to. So this will indeed clone down our repo effectively and get access to all that code. Okay, and we'll see there's a lot of user actions that are available, a bit like the NPM registry, right? Where it's open source, people can publish their own packages here. If ever we see any GitHub actions that start with this term actions, they're actually created by GitHub and maintained directly by GitHub. So that's that's our first step in this job: get access to the code. Okay. Once we clone that down, we only have access to what's on GitHub. So bear in mind, folks, anything that is Git ignored, we don't have here. So we would need our node modules. And how would you do that if you were just on your local machine? Just need to npm install. So I'm going to add the next step to this job here, and I'm just going to give it a name of install dependencies, and that is going to run just an arbitrary shell command like before. npm install. I just want to get hold of all my utils. I want to get hold of all my dependencies here. Cool. And once we had access to the code and we have our dependencies installed, what would we do again if this was our actual machine? We just want to run those tests. Now, if I just head to the package JSON here, folks, I have separated a test script here. Instead of just one npm test that runs all of the tests, I've got one for the utils specifically, and then one for the actual integration test for the app. But once we've checked out our repo, this virtual machine, as of finishing this step, has access to all of our repository code, including the package.json, meaning that we can indeed utilize the scripts that we already have. So I could now, I'm just going to give this step a name of just test our utils, which is going to run npm run test utils, one of our own custom scripts here that we have. Cool. So let's see how this looks. So Ben there says, do you need the .m files? We certainly will at some point. That's an excellent question. However, at the moment, these utils tests are just for our utils functions that you will have these tests in your repositories as well, folks, that are just for anything that they're unit tests, they don't require access to the database. Our .m files will only come into play when we need access to the database. And spoiler alert, that will be coming up. But let's just see this one in play at the moment, folks. Okay, so how do we get this on the go? I'm going to need to add this change as normal and commit it. So git commit -m add test utils job to workflow. Cool. And then I can now push git push origin this particular branch. Now we already have, folks, an open pull request here, and you'll probably notice that this week, right? If you've been asked to resubmit a pull request, you just need to. Oh, thank you very much, by the way, Haz, for approving that last one. If there is a pull request already in play, then if we were to commit and push, add, commit and push it back up to that same branch, it would just be added to the same pull request. So I just want to see that in play now. I'm going to push up to that branch. Come back here. I can see we've now got an additional commit here. And let's just see if we can catch it. I'm going to now head to actions. This set up workflow job, workflow has now kicked off again. Our greeting job was running concurrently with our test utils job. They're just running at the same time on separate virtual machines. And sorry, we missed it again. It happened so quickly. But again, setup job. It created a brand new Ubuntu instance for us online. Check out and clone repo. So that was our next step, right? It ran a particular action that already exists, to which the repository, my personal GitHub profile /NC news, it gets all of that code down and then install dependencies. It runs npm install. And this terminal output, folks, is going to be very similar to what you experience when you run these commands on your machine, right? It's the same thing that's happening online on this virtual machine. And then we got to testing the utils. Cool. It ran our script, npm run test utils. And we're seeing the jest output here. We're getting all of that back. And all of the tests pass, meaning that this step succeeded. So we then got to the next one. And this was our, if I just come back to our code, testing the utils was our last step in the job. But like before, there's some cleanup that the original actions will put in place. So post checkout and clone repo. Cool. Post checkout and clone repo. So that's just tidying up after the clone. And just as before, complete job, the virtual machine now ceases to exist. We've got all of our feedback. Everything's now finished here. Cool. So, time's it, 9:30. I am going to crack on, folks, just because I'm aware of the time. And again, I'd just like to remind us that all the steps I'm going to go through, they are indeed in your notes. But I'd like to get to the next one, because the next one's a bit more interesting. Musa there does ask, if you push something again to the same pull request that has already approved, doesn't it ask for a review again? In our case, no, it does not. That pull request has indeed, at the moment, where am I, already been approved. Okay, so if I just come back to this pull request now, cool. It has already been approved. So I might set up another one in a moment just to show that, because I'd like to make sure that the pull request is approved as well as something else. Okay, so yes, we've got this lovely green button, but I want to hang fire just for the time being, folks, before I merge this code in. Cool. So at the moment, then we have set up our pipeline and we've got it triggering the unit tests. So now, once the unit tests pass, because if the unit tests don't pass, I don't want to bother running the integration tests because they would be destined to fail. But once they do pass, let's now run those integration tests. So how would we do that locally? Well, on my machine, I'm just going to say npm run test app. Cool. And this is just running all of those tests that you've got, that you'll also have in your repos from this week. So I'm now going to need to add another job, right? So on the same level of indentation as greeting and test utils, I'm now going to create a job called test app. Cool. Now, we also saw, folks, that in terms of the actions, our greeting and test utils jobs ran concurrently. There was no requirement for one of those jobs to have succeeded before another began. And if we have a couple of small scale jobs, they might as well run concurrently just for speed. One of the main benefits of having a pipeline of this nature is if we've got problems in our code, we want to find out as quickly as possible that something's broken, okay? But in our case, I want to ensure that the utils test has passed, that job has completed successfully before we then move on to the integration tests. So I can now add a requirement here by literally saying this job needs, and then provide the name of any other job. And I can now say here, like test utils. This job needs test utils to have succeeded before it itself will trigger. Okay, but beyond that, what do we need to do here? Well, we need to repeat a lot of the same stuff, right? I need to say, again, every single job in this workflow, folks, is going to be on its own virtual machine. So I need to say, I'd like this also to run on Ubuntu latest. And I need to give it some steps. Cool. And what are these steps going to be? Well, first and foremost, I need access to that code again. So I'm going to take this step from the previous job. We need to check out and clone that repo using that pre-built GitHub action. Okay. I'm then going to say something else here. And then beyond that, it's very, very similar. I need to install all of our dependencies. Cool. By running npm install. And then I want to test our app. So in terms of name, test our application. And that's going to run npm run test app. So specifically only those integration tests. Now, the integration tests, folks, actually require our application to be fully up and running and access to our database, right? So when we're running locally, okay, when we're in a test environment, if we go back to that connection file, cool, if process.env.nodem is test, and Jest will do that for us on the house, set it to test, our .env package is going to go and read the appropriate .env file to then populate our process.env with that PG database environment variable to know how to connect to that database. Now, there are going to be two problems here, folks. One, this virtual machine does not have that database set up. It does not have that PSQL database already in existence in the background. And secondly, when we check out the repo, we only have access to the code and files that's on GitHub, right? And our .env files are Git ignored, and they should be, because they could be containing sensitive information. So we're not going to be able to gain access to what's in our .env files here, okay? But effectively, we sort of don't need to, right? And the reason for that is our .env.test file here is just to say, what is the name of the test database? If we now need to set up a database on this virtual machine, and as long as we know the name, we can provide that to this process. So inside of here, we're going to need to set up PSQL. Okay, so I'm just going to call this, set up PSQL. Cool. So how do we do that ourselves, folks? Well, we had to, if you're on a Mac, you had to actually install the application, and then you had to install the command line via Homebrew. If you're on Linux, you just had to install the PSQL client behind the scenes and then set up that database. Now, that's effectively what we're going to need to do here, right? And we'll be pleased to know that just like checking out our repo, this is such a common task that there is indeed a pre-built action for it called setup PostgreSQL. Cool. And it's showing us here that we just need to say uses. It comes from a lovely GitHub user called Harmon758. Thank you, Harmon758, / this is the name of the action. And we can come to the example here. And it's showing us that we need to now provide, sorry, I suppose it's a little bit awkward. We need to provide the name of a Postgres database. Okay. We need to provide a PostgreSQL user and a password. Those are the things that you would need locally to be able to access, to be able to create a database and actually access it via your no Postgres client. So I'm going to, I don't want us to use the term steal, but borrow this lovely pre-existing action and use it here. Okay. Let me just separate this one out because there's a few things going on. So we're going to use this action, but we need to provide some specific details to this action. It's going to need, think of it as almost like some variables, some data that it needs to set up our database as expected. Okay, so just like with the the checkout action that we saw before, we can provide a with key and provide some details. But we didn't need to do that before because it defaulted to our current repository. Whereas now we are going to have to provide some details to this particular action. So I'm going to say with, and then on the next level of indentation, the PostgreSQL database. PostgreSQL DB. And what do I want to call it? It doesn't really matter. I can just call it testDB. This database only needs to exist for the duration of this virtual machine's lifetime. And even the duration of this virtual machine's lifetime is only while this job is in the middle of execution. As long as our app knows the name of this database, then we'll be absolutely fine. So that's what I'm going to provide here. I'm then going to provide a PostgreSQL user, and we're creating one now. So it doesn't actually matter what this is. I'm going to call this person Mr. Testerson. That's my user in this example. And also going to have to provide a PostgreSQL password. Now, this password, we might think we do not want to just have written here, right? Because this code is going to be on GitHub. And how do we keep this sensitive? Well, what I'm going to tell us is it doesn't actually matter. The database that's going to be created is only in the virtual machine that has a short lifetime, okay? And the only way it can be accessed is from within this virtual machine. So I'm actually just going to blatantly, I'll sort of leet it up because I'm cool, right? But blatantly leave the password on display here because it's only the password to this database that will only exist temporarily. The only thing that we now need to think about is our test. Our test will already have the node environment, okay? Our process will already have the node environment set to test because Jest is going to do that for us, but we're going to need to provide this environment variable, the PG database, to be whatever our database is. We're going to need to provide that environment variable, okay? And we can do that just ahead of our script. So I'm going to say here, our PG database is testDB, whatever we called it here, okay? Our PG user is going to need to know that because that's not defaulting like it is on our machine. Some of you might have like that .pg pass file, right? If you're on Linux, that keeps, like, for example, your password stored away. You've already got a default user. We're going to have to provide that here, but we've just created it above. So our PG user is going to be Mr. Testerson, and we're also going to need to provide our PG password, which in this case we just created previously. Password, and then we want to run those integration tests just like we would locally. Cool. In the interest of time, folks, I'm going to get this pushed up and have a look. But if you've got any questions, please have them coming in. But let's see how this works. I'm just going to add these changes. Git commits. Add test app job to workflow. Cool. And I tell you what, I might do this on a different branch, only because I'd like to just have a fresh. I'd like to have a fresh chance of getting a fresh review. So I'll just call it checkOE, checkout to a new branch of, I'm just gonna call this add to GitHub actions. Cool. And now I'm just going to git push origin, add to GitHub actions. So the exact same code, folks, the exact same commits, just on a different branch. And now if I head back to our repository, see I will set up a new pull request here. And if I could very kindly ask Kaz, don't review this one just yet, if you don't mind. Cool, please don't be apologizing. I like your swift work. Cool, now we've set up this pull request. Some checks have kicked off. Let's go and look at our actions for this repo now. And one thing I'd like for us to see is the testing of the utils and the greeting are still happening sequentially. But we've got this nice visual indicator now that the testing of the app is connected to test utils and it requires its completion. And that's exactly what we wanted. Let's come and have a look at, once this job starts, test app, and let's just see what it does. Cool, so it's before set up a job. It's then going and grabbing that GitHub action for setting up our PostgreSQL database. Cool. And did it actually show us, I don't know if it shows us the details that we gave it somewhere. No, that's all behind the scenes. We're then checking out our code as before. Oh, brilliant. It's this one here. Sorry. Set up PSQL. Does it show us what it's doing? All this wonderful stuff. Cool. Oh, that was actually very, very quick. So we'd set up the actual database, then install the dependencies again. So that was just the npm install stage. Testing the app. Cool. We provided that those environment variables to our process, and then we're seeing that same jest feedback, but this is now the jest feedback for our integration tests. They're passing. Jest provides a successful exit code, so it tells GitHub Actions that this job completed successfully, and then GitHub has its own cleanups here, and that virtual machine, yet again, folks, ceases to exist. Cool. So let's just have a look at one more aspect. So we've effectively now done this bit, right? Whenever we submit a pull request to main, we're going to trigger the unit tests. When they pass, trigger the integration test with a local test DB. And assume that and once they pass, I would now like to have a little look at running the same integration tests, but on a live test database. Okay, this could be very useful for ensuring that, yes, this all works on our test environment. We might just want to stress test that and make sure, does it behave identically? Do all the same tests pass on our live one that we've got hosted with Elephant SQL? Okay, so let's just have a quick look here at, I'm just going to head to my Elephant SQL dashboard. And I've actually got two databases set up here, folks. The one that you'll have created as a result of hosting, a production database. Now, I do not want to interact with this production database at all. That's specifically for our live users that are enjoying our news articles and voting on them and adding their comments, right? We don't want to interrupt anything that they're doing. But I've just created another test database, but I've called this one like live test, right? And it's exactly the same setup, but I only want to interact with this from the pipeline during our integration tests from this point. So let's think about how we can actually do this. So first and foremost, back to our code. I'm going to add a final job here, folks, and I'm going to call it. So back on this layer of same layer of indentation where all of our jobs have been so far. I'm going to call this like just test app. I'm going to call it like live DB. Cool. Okay, so I would like to say that this job needs the completion of the integration tests with the local database. If they failed, there's no way that this job is going to succeed. So I'm going to say it needs the completion of test app, just like test app needed the completion of test utils, right? Inside of here. This is yet again going to be a brand new virtual machine, folks. It runs on, I'm going to say Ubuntu latest once again. And following that, what are the steps? Cool. So to begin with, exactly the same thing that we've had to do every time so far, folks, right? We need access to our code. So let's get hold of the repo. Now, for this particular job, we do not need to set up a local PSQL database. We would like to instead connect to our real database that's hosted live. So I don't actually need to set up, I don't need to do this, this step at all in this case, right? I would like to just crack on. So I'm going to take this one here. I'd like to install the dependencies. Brilliant. And then I would like to have our next job, which is going to be like test app with live database. Cool. Now, at the moment, right, our tests are set up to be in the test node environment. Okay. What I would like to do is I would like to run our tests, but acting as if they're in the production environment, acting because our production, when we're in the production environment, folks, if we go back to that connection.js, instead of connecting to a local PG database, if we're in production, we connect to our database URL, right? So what I'd like to do is I'd like to be able to run the tests here, almost effectively tricking our tests to thinking they're in production. So we connect to a real database, but I do not want to connect to my production database. And just to clarify, folks, I do not want to connect to my NC News production one. I've got a specific other one here, NC News live test. That's the one I'd like to connect to. So first and foremost, to make sure our pool is instantiated with a config object that looks like this, we need to have our node environment set to production. So I'm actually just going to do that here. I'm just going to say our node env is production. So it would work just as if it were in production. And now I want to provide a database URL. So again, we don't have access to our .env files, folks, right? And before, we just hard-coded that information in here. Now, this information wasn't sensitive because this is only a temporary database name, username, and password for the duration of that virtual machine. However, this database URL now actually points to a real one. And I do not want to invite any malicious folks to find that URL on my Git repository and start messing around with it. Okay, so I'm going to copy this here, folks. So this is my URL, and you're a trustworthy bunch, but I am going to delete that. I am going to delete that database after this session. So if I could just ask politely, but no one hacks me during the next 10 minutes, then hack away afterwards, please. So effectively, what I want to do is this. I want to provide this environment variable, but now this is exposed in the code. This is exposed in my code, right? And when this goes onto GitHub, you can come and you can just head into this YAML file, find it here, pinch it, and start abusing my database. So there is indeed a way to have our actions access effectively variables like secrets, right? So let's set this up. I'm going to head back to my Git repository, okay? NC News here. I'm going to head into settings, and there is an area here called secrets. And there are different areas you can leave secrets for, but I want to leave a secret for my GitHub actions. So I'm going to head to actions here, and we can now leave just very similar to when you're like hosting, or even when we're local with our environment variables, some key value pairs. I would like to create a new repository secret. Okay, none of these, I've done this in the past. I would like to leave a secret called like database URL. Have that be this value, okay? But once I click add secret, I can never see this again. That is now hidden. We can gain access to it, but all I can do in future now is change it. I've lost my opportunity to ever see that again. And now that value is protected. No, it's not in our code yet. Well, sorry, it's not in our code, and no one can get into there. Not even myself, the the main admin on this repository, can't come and see this secret now. Cool. So how do we access it from within our pipeline? Well, we get some what looks effectively like our string template literal syntax. It's just like the $ and curly brackets, but there's an extra layer of curly brackets in there. And we can access what effectively acts like an object called like secrets dot the name that we provide. So I can now say at the time of execution, please inject at this point in the code, whatever the value of that secret was, the database URL. Cool. So we've now got our node environment set to production, our database URL set to that real live database. And what would I like to do? What we were doing before, but connected to a different database now. npm run test app. Cool. Right, let's see what happens here. npm run test. No, sorry, let's just git add everything here. I'm going to git commit -m with add app test live db job to workflow. Cool. And I think in the interest of time, folks, I'm just going to quickly show something else before I come back to this. We already saw that if I get a review on my pull request, I'm free to merge in. But at the moment, if any of these jobs fail and my tests fail, there's nothing stopping me from just merging that pull request anyway. So before I actually do this, I'm going to head back to my GitHub repository here, back to where we were a moment ago on branches, and I'm just going to edit our branch protection rule. Okay. Now, one thing that I can now do here is we're already requiring an approval, but there's an extra one here that says require status checks to pass before merging. If I check that, cool, I don't need to bother with that one. If I were to check that one, I can now search for some valid status checks to be in place before merging is allowed. And I'd effectively like to check, I'd like to make sure that all of my jobs have completed successfully and all of those tests are passing. Okay, so I can actually look for, the names of the available jobs. So I could search for like greeting or test utils or test app, or in this case, test app live DB. Okay, so even if I come here, cool, I've got these options. Test app live DB. That now means that I must get a green light from that final step. I could say, I also want to make sure the utils test pass, and I also want to make sure the regular integration tests pass. But we've already set up that this final step relies on the integration test, which in turn relies on the utils. So I don't really need to do that. As long as this final one passes, we're happy to merge. So I'm going to save those changes. We've applied that rule. I'm going to come back to this pull request for add to GitHub Actions. Could I ask Kaz, would you be available just to be on hand to be ready to give a review? And I'm sure it's going to be, thank you very much. I'm sure it's going to be a glorious review. I'm now going to push this code involving this final job, including access to something that's now a secret. Okay, I'm going to git push origin, add to GitHub Actions. Cool, and let's see what that's done. Okay, so at the moment, what would be, I think, useful has, if you could just review that now anyway, I would hope for that to see that even though it's been reviewed, I'm still not allowed to merge until all of our checks have passed. And let me just quickly head to action so we might be able to see this in the flow. And we can now see, folks, we've got test utils must be completed before we get to the integration tests. And then when they're finished, that's when we get to running the same integration test, but on our live database, if you want to stress test it that way. Cool. I've got a little thumbs up from Haz. Let's just quickly check back. Add to GitHub Actions. Amazing. So now those changes have been approved. So I'm allowed to merge as far as my collaborators are concerned, but this button does not work yet because we've said that this job is required. This job is required to have been completed successfully. Okay. So let's just quickly head back to those actions. Cool. The integration test passed. Let's head back to this live DB. And we're doing similar things, right? We're going to set up that job. We've cloned the repo, installing dependencies. So everything that we actually need there. And test app with live database. And we can actually see here, folks, that the command that we've done is we've set our node environment and the database URL. It knows that that's a secret. So it's not exposing that here. It just says *****. It's getting that from behind the scenes when we set up that secret. Cool. Now this one, I'm sure, is going to take longer than previous, right? Because between every test, remember, folks, before each test, we're going to seed the database, but that's now a live database. So there is going to be a little bit more of a delay. But the thing that I wanted to check is that quite a while ago, we added this little test endpoint to the application. And this should only get into main once all of these checks have been completed. Cool. So this is almost where we need a GitHub action that performs some background music. I'm hoping this isn't going to take long, but as soon as it's done, if everything's gone well, folks, we're going to hopefully see that we've put everything correctly into play. So again, we've hopefully, so again, this has been an absolute whistle-stop tour, folks, but we've hopefully seen a real benefit of this tool, right? Being able to run any of our processes as part of our pipeline, just triggered automatically now by whenever we've submitted a pull request, that pull request is going to trigger checking the utils test pass, then our integration test pass. Then it's going to check that our integration test pass, lovely, with specifically our live database. Cool. Once that's finished, we get all of that. Oh, got an error. Oh no, I don't have an error. It told me there was an error momentarily. Cool, that's good news. It's completed that job. This job is now ticked. This virtual machine no longer exists. And if I now head back to the pull requests, cool, we should hopefully see that I'm now able to merge from both A, an approval, and B, those tests definitely passing. If I now merge this pull request, it's going to end up in main. So we've now just merged that branch, and we should hopefully see that if I come back to my live environment here, has it signed me out in the meantime? That's useful. Cool. There's now a brand new deploy in progress based on it tracking that new commit to the main branch. Cool. So yeah, just cheeky recap then, folks. So we had a look at some branch protection rules. Okay, hopefully we've seen some of the benefits of CICD and automating these processes. We can't have any rogue developers, okay, be it malicious or not. We can't have any accidental pushes from any collaborators to break our code in production. We've had a look at specifically GitHub Actions and their way of doing it. And we had a look at including sensitive data within our actions by using GitHub secrets, okay, and just accessing them that way. Cool. I don't think I want to keep us here to have a look at this. Deploy. It shouldn't take long. But I suppose the point is when we go to /API/hello, it's currently root not found that we got. And fingers crossed, when this builds, that new change, as revolutionary as that feature is to say hello on that endpoint, will then have been introduced into the code. Cool. Right. I would like to leave it there. I'll just leave this on screen for a moment. I've kept you 15 minutes over the allocated time. So that's where I would like to leave it, folks. Does anyone have any burning questions about anything before we say goodbye? Because again, everything that we have covered will be found in your notes, folks. Okay, so there is quite a lot of config. And again, this is such a surface scratch. There's so much that can be done with GitHub Actions. And again, I don't want any of you to feel the need to now have to shoehorn this into your projects. It just might be a little nice to have, something to play around with. If you get, if you're onto the further tasks, on the further tickets, might be something you might like to have a little play around with here. Cool. It's now listening on port 10,000. Cool. Let's give this another go then, shall we? And we now get our message of hello, everyone. We've updated our application with all those checks and balances in the pipeline. We made it. Well done. Cool. Right. Let's leave it there, shall we? Today then, if you want to just go have yourself like 5 minutes, back to your pull requests. Okay. Hopefully you found this session useful. As again, it has been recorded. So for those of you who are not here, don't worry about what I'm saying because you're not here. For those of you that are here, even if you want to review it, I will put the recording up just a little bit later. Cool. Thank you very much, everybody. Bye for now. Enjoy your days. Enjoy your final day of backend, the final push. Bye for now. See you later.